Today I'm gonna talk about the Eulers exam. It's a exam which helps you to prove Euler's formula and another to find e to the power of pi I. Okay, so now the first question, it is fx equals cosine x times plus I times sine x. So now we have to find the derivative of fx. So that's fx equals cosine x derivative minus sine x plus I times sine x. So it's I times cosine x. As I is like here it said, its square is minus 1. So I is literally just square root of minus 1. So it's a number, well, imaginary number. So its derivative should be 0. And so here we just plus 0 times sine x. It's equals to 0. So let's just erase it. Next, fx, we have to express it in the form of a times fx plus c. Okay, sure. Let's just copy it down. Okay, so now here the minus sign is I squared. So it's I squared times sine x. So we just get the I out times, okay, we have sine I squared, so it has one I remaining times sine x plus cosine x. And the center part here, this is exactly the same as this. So this is fx. I'm gonna erase the lines. Okay, it's equals to I times fx. And it's a equals I and c equals 0. Well, okay, next. Gx equals e to the power of xi. Well, that's then the derivative is I times e to the power of xi. Because ex, e to the power of x, it has a derivative of ex, and here we just replace x with xi and it will multiply a I in front. So now here it need to express derivative of gx in form of a times gx plus c. Well, here we can see very clearly this part. Well, I'm just copying it down. So this last part is the same as gx here. So it's just I times gx. Now this fifth question, we are gonna prove gx equals fx. So what we know is that derivative of fx equals I times fx. And derivative of gx equals I times gx. So we can know that the derivatives are equal. So derivative of gx equals derivative of fx. Okay, so now we need to integrate both of them. So what we get as a result is here cosine x plus I times sine x. Wait, we first write gx first, so we should write just gx first. So that's e to the power of xi plus c, and cosine equals cosine x plus I times sine x plus c. Well, we will use a different letter than c, or you will say, oh, it's cancel out. Well, it doesn't. So now we just minus this c to the other side, minus c. And d and c are all uncertain, so we can just write it, use a d, use a e to represent it. So we can set the x to 0 and we can try it. X to 0, this is 0 times, well, e, 0 times I equals cosine 0 plus I times sine 0 plus e. So now here e to the power of 0, because 0 times I equals 0, so it's 1. Also here, cosine 0 it equals to 1, and I times sine 0 it's equal, sine 0 equals to 0, so I times 0 is also 0, so plus 0, and plus e. So what, okay, yeah, actually there's e in front, so we'll use a different letter. So we will use f, yeah, no, f is fx. Oh, it's so difficult. Z, how about we use z? Yeah, plus z. Okay, so here we can see 1 equals 1 plus z, so z is equals to 0. So here we can see that gx equals fx as the remaining is 0, so gx, so it's what, e to the x of, and to the power of e xi equals cosine x plus I times sine x. So that's gx equals fx. Oh, this is a little bit large, but yeah, well, anyway. Here is e to the power of pi I. We have to find that. Well, here we got e to the power of xi. So we just turn that x to pi. As we have known here, it's e to the power of pi I, it equals cosine pi plus I times sine pi. And plus z, as z equals to 0, it's, we just plus 0 or we don't plus anything. So that equals to minus 1. So that's why we normally see like e to the power of pi I equals minus 1. That's the answer here.